Module 5, Graphs and Equations of Lines. This is Section 5.9, Review of Equations of Lines and Writing Parallel and Perpendicular Lines. We've used several different ways to graph a line. One of them uses slope-intercept. That's the y equals mx plus b1, where you have m being equal to the slope and b is the y-intercept. But there's also point slope, which you still need to find the slope, but then you can use any point, and it is a version, right, of the y equals mx plus b, where I have y minus y1 equal to m times the quantity x minus x1. M's the slope, and x1, y1 is a point on the line. It can be any point. It doesn't need to be the y-intercept. So if you wanted to find the equation of a line with a slope of a -2 that's going through the point -11, -12, I can substitute the m, the x1 and the y1 into my point slope formula. And then I can solve. A -12 is a +12. A -11 is a +11. Now I can distribute. I have -2x minus 22. I could either write it where my x's and y's are on one side, or I can put it in y equals mx plus b form by subtracting 12 on both sides. And the equation of the line would be y equals a -2x minus 34. If you're given 2 points, you'll need to first find the slope. You'll want to let one of the points be x1, y1, and the other to be x2, y2. And then it's y2 minus y1, so I'll have -1 minus a 0, and then x2 minus x1, 6 minus a -4 will give me a 10, and so my slope for this line is a -1/10. Pick one of the points. I'm going to go ahead and pick -4, 0, and sub that in for x1, y1. Even if you wanted to use x2, y2, you could still sub those in for x1, y1. So y minus y1, which was a 0, I have -1/10 times the quantity x minus the -4. So this is just going to be a y. And I have -1/10, and this is x. Well, -4 is a +4. Now I can distribute. -1/10 times x is a -1/10 x, and a -1/10 times a 4 is going to give me a -4/10. You can reduce the -4/10 to a -2/5. Let's look at another. If I have 2, 5 and -4, 3, I'm going to let this be x1, y1, and this be x2, y2. I need to find that slope first, so I'm going to have m is equal to y2 minus y1 over x2 minus x1, and I'll have a -2 over a -6. Negative divided by a negative is a positive, and I can reduce 2 6 to a +1/3. Now I can take my 1/3 and sub that in for m, and then pick a point. I'm going to use 2, 5. So I have y minus 5 equals 1/3 times x minus 2. Distribute, and I have y minus 5 is equal to a 1/3 x minus 2/3. If you don't like to deal with fractions, you can multiply everybody in the fraction, in the equation, by the common denominator of the 3. But you have to do it to every term in order to get it to work. So now I have 3y minus 15. This is going to become a 3/3, which is a 1, and this would be 6/3, which is a 2. Since I have a coefficient in front of my y, I'm going to write this in what we call standard form, where the x's and y's are on the same side together. So I'll subtract x. So I have -x plus 3y, and I'm going to add the 15 to both sides. And so I'll have -x plus 3y equal to a +13. If we want to talk about parallel and perpendicular lines, remember that parallel lines have the same slope and perpendicular lines have slopes that are negative reciprocals of one another. But before you start looking for what kind of slope any given line has, you have to make sure that it's in y equals mx plus b form before you start looking for the coefficient of x. The only time you can pull a slope from an equation is when it's in y equals. That's the only time that the coefficient of x is your slope. Let's say we want to find the equation of a line that contains the point negative 2, 4, but I want it to be parallel to x plus 3y equal to 6. Before I do anything, I need to get this in y equals mx plus b terms. So I subtract the x over to the other side, and I get 3y is equal to a negative x plus 6. Now I'll have to divide everybody by a 3. And I get negative 1 over 3, so negative 1/3 x, and 6 divided by 3 is a 2. Now I can pull my slope, and the slope is a negative 1/3. If I want the lines to be parallel, the slope for the new equation must also be a negative 1/3. That gives me my parallel slope. The symbol for parallel looks like 2 L's. Well, my parallel slope is going to be a negative 1/3, and I want it to go through this point, so that's going to be my x1, y1. I have y minus 4 equals negative 3 times the quantity x minus a negative 2. I'm going to multiply both sides by 3 so that I don't have to deal with that fraction right away. Now I can distribute, and I get 3y minus a 12, and then over here, well, this is going to be a positive 2, but when I distribute the negative 1 through, I'll have a negative x minus a 2. Now let's put it into standard form. I'll add x to both sides. So I have x plus 3y minus 12, and now I'll add 12 to both sides. And so the equation of the line is x plus 3y equal to 10. If you wanted to find a line perpendicular to another line, we would have a similar process, but those slopes would be negative reciprocals of one another. So if I wanted to find the equation of a line that contains a point 3, negative 5, but now is perpendicular, I need to still rewrite this. I still need to subtract 3x from both sides so that I get 2y is equal to a negative 3x plus 7, and then divide everybody by a 2. And I get that the equation of the line, another way to write it is y equals negative 3/2 x plus 7/2. Don't worry about that. It's the slope that we're interested in. The slope of this line is negative 3/2. But perpendicular lines have slopes that are negative reciprocals. So you need to flip the fraction. So this is going to become a 2/3 and then change the sign. It's negative and it becomes positive. So our perpendicular slope, and the symbol for perpendicular is an upside down T, is going to be a 2/3. Take your slope and the point that you're looking for, and let's substitute that into point slope formula. So I'll have y minus a negative 5 equal to 2/3 times the quantity x minus 3. Again, I'm going to multiply both sides by 3 so I don't have to deal with that fraction right here. And a negative 5 is a positive 5. This is going to turn into 6 over 3, so I have a 2. Distribute on the left, and I get 3y plus 15. Distribute on the right, and I get 2x minus 6. I'm going to move the x over to the other side, so it will be in standard form. Minus 2x from both sides, and I get negative 2x plus 3y plus 15 is equal to a negative 6. When I subtract 15 from both sides, I'll get negative 21. The line that's perpendicular to the given line that goes through the point 3, negative 5 is negative 2x plus 3y equal to negative 21. And that's your review for your Module 5.